Hello and welcome back. I just want to give you a few examples of solving quadratic equations using the factoring tools from the previous couple of videos. So let's start with a quadratic equation. Remember, quadratic expression is just the ax squared plus bx plus c. Quadratic equation usually just has that set equal to 0, or maybe it has different things on different sides and you have to get them onto one side so that there's a 0 on the other. So here's an example. It's already arranged correctly, so we don't have to do that. But you could imagine this coming from 4x squared equals 7x plus 2 or something like that, and you have to get everything on one side. Now this has a coefficient of 4 on the x squared term, so you could do this trial and error method. I think I'll just use the AC method. There's no common factor. This is a 7 here, so I can't. First thing I'm going to check for is can I factor something out of everything? Can't do that, so looks like I'm going to use the AC method. AC is 4 times negative 2 or negative 8. That's a negative number, so I'm looking for a difference. And I'm hoping that that difference is negative 7. Well, or I can just say 7. We'll deal with what the signs are of the two numbers in a second. The larger of the two will be negative because it's a negative 7. Well, you may have guessed what two numbers multiply to 8 or negative 8 and whose difference is 7. Well, that's 1 and 8. So we're good to go. So now we just split up that left-hand side, the x terms on the left-hand side, 4x squared. Which one's negative? The one who's bigger. So we're going to do minus 8x plus 1x minus 2 equals 0. Factor by grouping. Factor out a 4x out of these first two terms. Get an x minus 2. And lo and behold, we have an x minus 2 here already, so you can think of there being a 1 here, if you like. And then we factor that one more time, 4x plus 1 times the x minus 2 that we pulled out. So that leaves us with two equations. Our principle of zero products says if you've got two things multiplied together and they equal 0, then one of them is 0 or the other is 0. So we have 4x plus 1 equals 0, or x minus 2 equals 0. When it's something simple like x minus 2 equals 0, you can usually just read it off. Oh, that means x has to be 2. If it's a little bit more complicated, you may have to do a little bit of solving. That's fine. Subtract 1 from both sides and you get negative 1. Divide by 4, you get negative 1/4. So our solutions here are x equals negative 1/4 and 2. How about this one? X squared minus 11x plus 10 equals 0. Feel free to pause the video and see if you want to see if you can do it. The a is 1, so this is a straightforward normal-ish factorization. We need to find two numbers that multiply to 10. They're the same sign because this is positive, so they have to sum up to 11. And they're both going to be negative. Well, what two numbers multiply to 10 and add to 11? It's 10 and 1. Or 1 and 10. You could write these in whatever order. Equals 0. So this one's pretty straightforward. So that means x is 10 or 1. Some people might write it as the solution set. You could write this the solutions as a set using curly brackets. Use curly brackets to represent a set of numbers. So you might see that occasionally. When I'm usually writing the solutions, I'll just write it like this, 10, 1, unless something requires me to write it as a set. How about this one? So say we need to solve this guy. Find the x values that make this true. You can do this. You can think of this as 16x squared plus 0x minus 9 and factor it normally with the AC method and all that. But notice it's got two terms. It's a subtraction here. These are both perfect squares. Oh, this is a difference of squares. We can factor this using our special difference of squares idea. So this is the 16x squared is the square of 4x, and 9 is the square of 3. So this is 4x plus 3 times 4x minus 3. equals 0. And what that gives us is two equations, 4x plus 3 equals 0, or 4x minus 3 equals 0. So x equals negative 3/4 or positive 3/4. And you can write that as negative 3/4, positive 3/4 if you like. Now notice, we've got a number, a positive and negative version of the number. This might look familiar. You could have solved this equation kind of like we did a while ago by adding 9 to both sides. 16x squared equals 9. And then divide both sides by 16, 9/16. And then take the square root of both sides. But remember, I said when you take the square root of both sides, there's actually a positive and negative solution to this of 9/16. Well, square root of 9/16 is square root of 9 over square root of 16. That's 3/4. So you get the same answer. How about this one? Well, might as well use equal variables amendment. Let's use a different variable. 4y squared minus 20y plus 25 equals 0. Again, AC method will work here. AC is 100, right? Find two numbers that multiply to 100 and add up to negative 20. They're a sum, right? So that's 10 and 10. Two numbers that multiply to 100 and add up to 20, that's 10 and 10. They're both negative. You'd be pretty much, and immediately you might go, oh shoot, if I had only noticed that this was a perfect square, because this is going to be something minus 10 and something else minus 10. It's going to be the same two factors here. Well, that's because 4y squared is the square of 2y. 25 is the square of 5. They both have to be minus because of this guy here. Now, I have to check. I have to check to make sure. Does 2y times negative 5 doubled equal 20? 2 times 2 times negative 5 is negative 20. Yes, it equals negative 20, which is what we have. So that checks out. So yeah, indeed, this does have that form of a squared plus 2ab plus b squared, which is our perfect square. So we just put the square here, equaling 0. Now, normally you'd have two factors, 2y minus 5 equals 0, making two different mini equations, but in this case, they're the same equation. So really, it's just one. So in some sense, we just have a repeated solution here that's represented by just this one equation. Repeated solution, or in other words, a single solution. Y equals 5 divided by 2. That's the answer. So I hope that gives you a little bit of overview of the types of uses for factoring. Once you get a little bit quicker with factoring, you can solve these quadratic equations pretty quickly with a little bit of effort sometimes with factoring. And if you get stuck factoring, well, the next section gives us a tool, the quadratic formula. But that's all I have for now. See you next time.